Hello guys, am I audible? Yeah, I think I'm live. So we had, we will continue on day two our grind. Day two, yeah, we'll continue the grind. So, okay, my internet seems low. Okay, so we already have solved the first problem, needle in a haystack, and we were on the second problem, wishing cards. Hmm. Okay, so what this problem saying is basically it is said that writing wishing cards on New Year's Eve can bring good luck. Okay. You have written wishing cards and plan to give them to little A. Okay. So little A is a person or what? You have invited N friends to help you deliver the wishing cards. Oh, N friends. Okay. You plan to give the ith friend BI wishing cards. Okay. The friends will visit little A's house in the order of 1 to N, and each will hand over all his BI wishing cards to little A. Okay. Little A always remembers the friend who gives her the most wishing cards. Oh, okay. So after the Jeth friend visit, she gains happiness equal to the largest number of cards received so far. That is maximum of B1 to BJ. Okay. The ith friend can carry at most AI cards, and the total number of cards cannot exceed K. Okay. Your task is to optimally choose values of BI so that the total happiness of little a after n visit is maximized under these constraints. Okay. Note that some friends may carry no cards at all. Little a won't get mad. Mhm. Okay. This seems to be a little complicated, not much, but seems to be little complicated. Okay. Uh, let's see what we can do. Uh, each test case contains multiple test cases. Each contains two integer n and k. Okay. And the maximum total number of cards. Second line contains n integers, the maximum number of cards each friend can carry. Mm-hmm. It is that the sum of n over all test cases does not exceed, and the sum of k over all does not exceed. For each test case output, the maximum happiness little a can get. Okay. So, and friends to help wishing deliver cards. So, what I can do is like the basic approach that is coming in my mind is to just give one friend all the maximum cards. So, the ith friend can carry. You have invited n friends. Okay, let's again read this problem. You have invited n friends to help you deliver the wishing cards. Your plan to give the ith friend BI wishing cards. Friends will visit little a in order from 1 to n, and each friend will deliver all his to little a. Little a always remembers the friend who gives her the most wishing cards. So after the jade friend visit, she gains happiness equal to the largest number of cards received so far. That is max of. Little a so That is, the ith friend can carry at most AI cards, and the total number of cards cannot exceed K. Normally choose values of Pi so that the happiness of A. I mean, happiness is maximum value, right? So I can just give all the cards to one person. In the end, last person I can give all the cards and she will get the maximum happiness, right? Or no? Sum. I think maximum happiness is the sum, right? Mm, she gains, right? Okay, got it. I thought I can give all the cards to one person, but no, that would not be the case here. And since we can see that from the problem tag, it's a dynamic programming problem, so we have to think from that perspective. Um, okay, so mhm. So what I am understanding is that there are, let's, okay, there are n friends, right? N friends, uh, and total happiness after. Okay, so the first test case, each test contains two integer n and k, the number of friends and the maximum total number of cards. Okay. Uh, let's take the second example, right? 6 and 8, 6, comma 8, and okay, these are basically are n and k, and 120518 are okay, limit of basically how much each friend can 120518 518. These are the maximum cards a friend can carry, right? Total number of cards is 8. Okay. And we have to, okay, we have to divide the cards in such a way that the sum, like, let's say this is the happiness array, right? Let's say, 1, 2, 3, 4, 6, 7. Okay. Okay, I've created one more, but this is the array, right? So, what I have to do is basically I have to maximize. So, at any j, at arbitrary j, uh, okay, what I need to do, maximum happiness will be b1, max of b1, b2, till bg, right? We know this. Okay. Okay, we know this. So what we can do is mm, here. So first friend can give maximum of one card, right? So we can give one card, or we should not give any card, right? It should be one or zero. So it's a since we can see in the problem tag it is mentioned that it is a DP problem. We have to think from that perspective. So in DP, what is how how can we identify if a problem is a DP problem, right? So I also don't know that much about DP. That's the reason my rating is 865. I'm currently in the learning phase, trying to understand DP in depth more. So basic what I can understand is that if we can work how we can understand if it is a DP or not is if we have some base cases and if we have some base cases, right? uh, if we have some base cases and uh we can work upon our solution on those base cases, then that's a DP problem as far as I know. So some case and work upon those base cases. So I'll just add some timing here so that we don't take much time. If we are not able to solve in a specific limit of time, we can always go to solution and understand it, right? It's no point in wasting a lot of time here. So I have this array, right? Uh, okay. So can we identify something here? Like, can we identify something that makes sense? Like, uh, let's say I am on the first, right? So what can I do, right? I have two options. I can either give card one, right? Yes, right. I can either give one card. I can either give two cards, right? Or I should not give zero cards, right? So I can give one, two, or zero for one, right? I mean, the limit is one only, so I can only give one or zero for one. So I can go here, keep on going downwards. So what I can do is let's create some 6, 8, and K, and we have 1, 2, 0, 5, 1, and 8, right? 1, 2, 0, 5, and 8. Okay. So uh, okay, let's say we are on the first index, right? Mm. And what uh in DP we have to also identify the number of changing states. So 1D DP, 2D DP, or 3D DP kind of stuff. So um, what are all the things that are changing here? So first I can identify that index, right? We will be updating the index. So index is one that is changing. Index is changing. Uh, right. That is like easily we can identify that index is changing. What is the second thing that is changing here? Is there a second thing that is changing? Uh, I think yes. So second thing is after each index, k is also being modified. So k is changing, right? So which makes this a 2D DP, if I'm not wrong, right? This makes it a 2D DP, right? And yeah, so uh we need to think from that perspective. It's a 2D DP. Okay. So index is changing and k is changing and it's a 2D DP. So okay, how will I proceed? Uh guys, I'm also thinking if you have some approach, you can start mentioning them in the comments. Uh, I don't see any comments right now, but okay. Okay, so what can be the approach? How can I approach this problem? Uh, is there some solution that is coming into uh so let's see let's see the limits and see if we can get so key can be only till 360, right? Okay, key should be less than equal to 360. Okay, and and should be less than equal to 10 raised to the power 5. Okay, so at each index I we can have almost 360 different values, right? So this will this will this will result in around 3 raised to the power 3 into 10 raised to the power 7, and it will not give us TLE. It is it is uh, it can be done in this form. So hmm, okay. So that makes sense. Okay, so I can have 360 different, but it will not be I into 360. It will be mhm, and the limit of BI is we have given the limit of BI. Okay, AI is between 0 to yeah this sorry not BI AI. So we have also given the limit on AI. So AI should be less than or equal to K. So at most at each we can have K value. So 2 to the power K at each, right? Dot 2 to the power K dot 2 to the power K till 10 to the power 5 to the power k. So it will be like 2 to the power k into n raised to the power 5. Oop, that's a really, really big number. Okay, so that doesn't make sense to just to go through this way. There should be a better way. Okay, let's identify that what we can do here. Uh, we have to maximize the gains, right? So here by the third test case, what they have done is they have given 5 is the answer. So 3, 4 total number of is 4. So they have given 1, 2, 3, 8, 1, 1, and wait, what? Maximum we can wait. I think we have misunderstood the question because if the maximum we can give is the third test case 104 is invalid because you only have equal to 4 vision cards. I think we have misunderstood the question. Uh, you have invited and friends to help you deliver the wishing cards. Your plan is to give the ith friend vision cards. The friend will visit little A's house in the order from 1 to n, and each will hand over all his wishing cards to little A. Little A always remembers the friend who gives her the most wishing cards. So after the jth friend visit, he gains happiness equal to the largest number of cards received so far. That is. Oh, okay. I mean, then we can just give all the cards to the first, right? And give nothing to anybody. But but that's the limit, right? We can only give one card to first. Okay. So give one here. One maximum will be 1, 2, and remaining 3 will be spent to this. So maximum will be 2 plus 3, 5. Okay. Okay, that makes sense. That makes sense. So I think one brute force approach that is coming in my mind is to give the maximum cards from left. So let's say here I have 120518, right? Okay. I have 120518. Why not give k is equal to 8, right? Why not give one card to him, two card to him, 0 to him, 5 to him, and 1 to him, and again 0. This will give us 1 plus 2 plus 2 plus 5 plus 5 plus 5, right? That will be our answer 20. Okay, that makes sense. That makes sense. That is, yeah, that is making sense, right? But we cannot we cannot use uh, brute force here as we have used here because let's say if it has one three cards, right, and here it is uh five only, right, five, here let is one and eight. Sorry guys. So if I have distributed three cards, right, then here only I can distribute four cards. So what will be my answer? 1 plus 3 plus 3 plus 4 plus 4 plus 4. So 12, 15, 18, 19. I'm getting 19. But if I follow the top order, I can get 20. So this is not optimal to give all the because there is somebody that is bigger than him in the future, which if we give him more cards, then it will be more optimal, right? Okay. So uh okay. Uh, I think Mm. What we can do is let's write some brute force. So I what I'm thinking is at each index uh we have, let's say we have k cards, right, k remaining cards. So and we have some AI, right? So what I can do is okay, okay, again. Okay, I have some shapes, so there is no AI, right? So what I can do is uh I can iterate over all k, right? Either I can give one card, two cards, or k cards, and 1 2 0. Let's write some. Okay, let's write this. Let's create a tree. Uh, let's create some tree to understand it in more depth. I have one, two, or or I'll create one tree, right? That is 1 3 0 5 1 and 8, and his 6, k is 8. Hmm. So on first index, I have two options, right? What if I give I am on index 0. I have 8 cards, right? So what are changes there? Let's give one card. So answer will be calculate mid answer. Uh, okay. I'm not able to think, guys. Let's see the tutorial. Mhm. Um, so this is the tutorial, right? It's a 3D DP. Let's start with some simple DP solutions. As we go through the friends left to right, what is important for us to continue? It is how many elements we have chosen. I. There some S. Here maximum M and the current happiness of little a. H. Okay, as usual of these four numbers, three have to be DP parameters and one has to be DP result. The most natural choice is DP ISM max of H. The transitions are trivial. Loop through BI, update DPI accordingly. This is solution which is quite slow. Okay, we need to add two optimizations. The first one is to get rid of n factor. This is quite easy. If you want to use pi equal to x at some point, you do put as early as possible. That is at first. This means that from the whole array, we only need the prefix maxima, which leave us with an array of length at most k. The second optimization is to get of linear transitions. Instead, we can do backward looking DP and compute as dp of I as where t is arbitrary to choose this maximum. No loop is needed as we can pre-compute this for every s minus m. Okay. By reading this also not getting much idea because I think we have to read it in depth. Oh, did I just set the clock or not? Because I think okay, 3 minutes are still left. I gave up too early, guys. There were 3 minutes are still left, but okay, let's see. Okay, it's a 3D DP problem. Let's start with some simple dynamic programming solution as we go through the friends left to right. What is important for us to continue? Oh, okay. So it's not a 2D DP, it's a 3D DP, guys. It's a 3D DP. Okay. So we have this 130518, right? And mm, what it is saying is hmm, mhm. So it is how many elements we have chosen I. Here some S, their maximum M, and the current happiness of little a H. Uh, Mhm. So the first one is to get rid of the n factor. There are some comments also I was reading. I change one letter my code accepted in question. Runoff is another solution. Mhm. Okay.